and welcome to the Chainlink workshop for the Bear Necessities Hackathon. Chainlink is a major sponsor of the Bear Necessities Hackathon and a continual collaborator with us. We're so happy to be able to work with them. And today we have a very special guest. We are joined, and we're very lucky to have Richard Gottleber. And Richard joined us for Moon Builders Workshop back in December, which was fantastic. And today we have some exciting content for you. So Richard is a teacher masquerading as a developer advocate. He began his career behind a support desk, and he worked on the entire technical stack from system administration to front-end development with a pit stop as a fifth grade math teacher and science teacher. Today, we're going to have a fantastic workshop. We're going to be discussing Chainlink price feeds on Moonbeam. And of course, we'll be discussing the hackathon bounties, which Chainlink has a very open-ended bounty for the Bear Necessities Hackathon. You can pretty much build whatever you want. There are no specific, prescriptive requirements. It's really open and up to you. So thank you so much for joining us today, Richard. And with that, I want to hand it over to you, and also mention that if anybody has any questions, feel free to drop them in the chat. This is meant to be interactive, and we'll have a chance. At the end, we'll have plenty of time for Q&A.
Yeah, sure. Thanks for the introduction, Kevin. As Kevin mentioned, I'm Richard Gottleber. I'm a developer advocate at Chainlink Labs, and today we're going to talk a little bit about what is Chainlink. We'll get to a hands-on demo, so if you want to follow along, you can for sure. I'll be watching the chat, and then at the end, I'll go into the Q&A stuff for any questions you have. But if you have anything in the chat, I'll try to keep an eye on that too. I am by no means a Twitch streamer level person who can split my eyes between the screen and the chat, but I'll do my best there. I do have some questions for you all that I will ask you to answer in the chat. They're not too hard, but they should be good. So let me go ahead and share my screen and we'll get started. While I do that, where's everybody from who's in the chat right now? I myself am in Texas. Miami, Colombia, awesome. San Francisco, yeah. Australia, whoo. What time is it in Australia? I feel like it's a rough time there right now because it's not bad for me. If it's good for me, it's bad for Australia. So we will, midnight, I'd be asleep already. We will start off by asking, what is the question of what is Chainlink? So Chainlink is a Oracle network. It's a distributed Oracle network, or DAWN. But before we go into that, I'm sure you all know the purpose of smart contracts, but just to make sure everybody's on the same page, we'll kind of cover that. Traditionally, agreements required a third party, and that can lead to a bit of trust relying on that third party, right? You sign an agreement, and the only reason that it's enforced is because you have a third party here who will help you enforce it. We've got Colombia, Australia, the United States. I live in the United States. I know here, most of the time, the legal system works just fine if you have a contract. Sometimes maybe you didn't understand everything in the contract, or it doesn't work quite right. And that can be a problem, right? If those agreements don't happen the way that you expected them to, because they're not being enforced correctly. So that trust is broken. That's where smart contracts come in. They take the place of that middleman. And now you have cryptographic truth instead of that trust being what is backing these agreements. And to me, that's one of the powerful and important things when it comes to Web3, and why I think that this technology overall is so important. But when we talk about blockchains, we come up with this problem of consensus, because that's how they work, right? We have a bunch of different nodes within the network, and they all need to agree, or at least most of them need to agree, to reach consensus. And consensus is easy some of the time. If I were to ask everybody this question, and feel free to pop the answer, it's not a trick question. What's 1 + 1? Go ahead and pop the answer into the chat. Window, it's 2, yes. So 2, right? 2 or 11, yeah. So I said it's not a trick question, just 1 + 1 is 2, right? We can all agree. We can reach consensus on that. That makes things a lot easier, right? When we're talking about, if we imagine each of us being a different member of a blockchain network, right? We're different nodes in that network and we all need to agree. When we see this question, 1 + 1, we agree, it's 2. It's really easy. Now, I'm gonna ask you the hardest question I'm gonna ask you today. What's the current temperature? And especially since we have people from, outside the United States who use probably a more sane tool to measure things in Celsius, like I'm gonna say in Fahrenheit that it's 74 degrees here in Texas. It's 22 degrees Celsius. Like I don't even know what that means, but like I think that's pretty okay temperature wise. Cold, right? So this question is an it depends type of question, right? It depends on where you are. It depends on when specifically you answer this question. If you think back to 1 + 1, that's a deterministic or non-deterministic question where, that question always is going to have the same value, right? We think back to 1 + 1, and it doesn't matter when or where you are when you ask that question. That's easy for blockchains to answer. With a question like what's the current temperature, it depends when, where you ask that question. Those type of questions are non-deterministic. They're hard to answer when it comes to blockchains, right? Because we can't really all agree. Like even here, there's just a couple of us answering this question. We can't agree on what the current temperature is. And that leads me to feeling like blockchains, the cryptographic truth, it reminds me of Genie, phenomenal cosmic power, itty bitty deterministic living space, right? We have this set of constraints around blockchains of deterministic values that makes things very challenging. It's commonly referred to as the Oracle problem. And this is what Chainlink solves, is the Oracle problem. So having that distributed Oracle network allows us to have oracles, which ironically are the solution to the Oracle problem, where you can bring off-chain data on-chain. Now, if we take a look at this diagram, on the left hand, we have different data sources, right? We have everything from temperature to sports scores to valuation of currencies. And you could definitely set up a single node as your oracle to bring that data on-chain. That would work. But if you notice, the decentralized nature of blockchains is essentially being centralized then if you only have one node. And you start to reintroduce the trust that we're trying to get away of in a trustless environment. If something were to happen to that one node, it could destroy the entire process, right? If one node goes down, your data sources aren't available, suddenly now you don't have the information on chain. And again, this goes back to the idea that Chainlink is a distributed Oracle network. So it kind of looks like a regular blockchain. We have different Oracle providers who are all managing their own oracles, and they give their information together to reach consensus. So when it comes to the Moonbeam networks, what does Chainlink offer? So it's going to be data feeds. And as the name implies, data feeds are going to be about getting different feeds of data on chain. The most common one is going to be asset pair data, and we'll take a look at what that looks like here in just a minute. But essentially, that's going to be an asset paired with another one, and so you can get, like Glimmer in terms of USD or something like that. So we'll go through the documentation. We'll actually go through building out a smart contract, talk through all of that. And if you want to follow along, you're more than welcome to. We'll be using Remix. And we'll actually deploy and interact with price feeds. And yeah, that's our next steps. But I'll take a moment here to pause. Any questions so far about what I've covered? Do we need to use ZKPs? So we don't. I can explain to you kind of how this works as well for that. All right. So the first place I'm going to head to is data.chain.link. That will greet you with a page that looks like this. If you scroll down just a bit, you can explore the data feeds. And here I've filtered out the networks just to have two of the Moonbeam and Moon River networks. So we can take a look at some of the feeds that are specific to those two networks. If we pick one here like Link USD, we can get a sense of how data feeds start to work. So on the left-hand side, we're going to have all the information about this data feed, right? So like the trusted answer that's coming back, what network we're on, what other networks this data feed is available on, a little bit of information about what we're looking at, some trigger parameters. So what this is this is going to be what causes this data feed to update. So if there is a deviation in the price itself of more than 0.2%, that would trigger the actual data feed to update that trusted answer, or if that heartbeat occurs. So the heartbeat's going to be based on, it looks like it's roughly 10 minutes on this one. It's going to vary depending on which asset we're looking at and which network. But if that heartbeat occurs, then we'll automatically update it. Now, a lot of times people ask, well, how often is it checked, right? And it's going to be checked every block. So every block that goes by, this trigger parameters will be checked. And so if they need updating, they will. It's kind of an interesting way to think of it, because when it comes to the actual answer that we're getting back, that's stored on the blockchain. And since that's stored on the blockchain, it does cost gas, right, to update that value. So we don't want to be updating it necessarily every block unless we need to. We can see here too on the bottom left that we have the Oracle response. So there's 16 oracles and 16 of them are responding. And it was last updated 4 minutes ago. You can also see the contract address for this actual price feed. On the right-hand side, we have the oracles themselves. So these are all the different oracles that are reporting back their prices. And you can see here that there is some variation in the prices that are coming back, right? We have, just a couple hundreds, thousandths of a cent different here. But that's different, right? When you think about our question, what's the price of Link in terms of USD? And you think about, does that sound like a 1+1 question, or does that sound like a temperature question? To me, it sounds more like the temperature question, right? Because it's something that fluctuates. It can change a little bit. And we can even see that here. If you think about these as being, when we ask that question within the people who are on this call, and you think about the different answers we had for temperature, we have different answers too to the question of what's the price currently. But when it comes to something like this, what we're actually asking is, what is the trusted answer? And so given this set of data that we have here now, we can take what would be a non-deterministic question and turn it into a deterministic one, because we're saying, given this specific set of data now, what's the median price of all the different reported values? And so that's how we can start to take a non-deterministic value and make it a deterministic one when we're using oracles like that. I know it's kind of a weird concept, maybe, if you're not familiar with it. If you have questions, again, feel free to just pop them in the chat. I'll be keeping an eye on it. I just want to make sure I'm being clear and everybody's understanding what I'm saying. So we have here, our price feed. If we wanted to actually interact with this, the best place to go for that is the documentation. And so if you head to, playing around earlier, docs.chain.link, you'll see our documentation. Now, I often say how amazing our documentation is. I just want to give a shout out to the Moonbeam team that their documentation is fantastic too. We'll take a look at it here in just a minute, because they seriously have some of the best documentation as well. I'm super impressed. But our documentation is going to be where I start personally for anything that I'm looking to do. So we're talking about data feeds. It's the first thing here. You can see the different networks that have the different products available. We also have some things like functions and automation and VRF. Currently, they're not available on the Moonbeam networks. So, that's unfortunate, but, keep your eye out in the future. They may be there. When it comes to data feeds, we just go into the documentation for that. It'll explain data feeds to you, what's available and everything like that. We'll be looking at price feeds specifically. So if we go to price feeds, we can actually take a look at this learn how to read data from it. And we have a sample contract right here. Now, one thing that I love about working in Web3 is Remix makes things really easy when it comes to demos and trying things out. It's fantastic. So we have our example contract here, and we can just click this button, open in Remix, and it'll take you to Remix, which is a online IDE. It does everything right here in your browser. You can do everything from deploying contracts to a virtual network to actual networks from Remix. If you haven't messed with it, it's super powerful. If your contracts get too complicated and interconnected, things can get a little too much for Remix, at least in my experience. But for most things, I use it all the time. So let's walk through this contract. The first thing we see here is we've got our Solidity compiler version, and then we import this aggregator v3 interface contract from Chainlink's contracts. Now, what that is that's going to be the interface for actually doing that response aggregation. If we look back to here, we have our different oracles, right? And so we need to aggregate all of that data together into our trusted response. So that's what we're importing there. Then we set up our contract, it's called data consumer v3. We have our aggregator interface that we'll be calling data feed. And these examples, most of the examples in the Chainlink documentation are set up to work on the Sepolia test network. And this one's for Bitcoin in terms of USD. If we wanted to look at this on one of the Moonbeam networks, I would go to the Moonbeam documentation for like the Moonbase alpha values here. So we'll stay with the same thing. We'll stay with BTC to USD. We'll need to grab the actual address here for the data feed. So we'll copy that out. So it's going to replace these values in our contract. The reason is each different data feed has a different contract associated with it. So we need to make sure we're applying the right one. So this was for Moonbase Alpha, I believe. Did I spell that right? Hey, I did. Okay. And then we also need to make sure that we're on the right network as we're doing this. Cool. So we set up our data feed. We give it the aggregator contract, the aggregator interface contract address. And then we have this function of get latest data. This is a pretty simple contract. It just has one function in it. All it's going to do is get the price from the latest round of price updates. Now, I have like a pop quiz, and I'm curious if anybody knows the answer to this. In our documentation, we have all these commented out values here. Anybody have any idea why they're commented out? I'm always curious. It's a fun little trivia piece for Solidity. And it's probably also one of my least favorite things about Solidity. It's not encode test. So if we were to uncomment one of these, yeah, so we don't need them, right? Like, and if we uncomment it and then we don't use it, it gives us this awesome warning that like, hey, you have an unused local variable. So we've commented them out to keep them in here so you can see what else would be returned. But the proper way, and this just, every time I do this, it's just ridiculous to me. But the proper way to have this function signature, like when you're using this, would be like this, you know. So we've got the good old comma, int answer, comma, 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 which just is really, you know, undev friendly in my opinion. It's probably my least favorite thing about Solidity, but hey, if that's my biggest complaint, it's not too bad. So we leave those in there just so we know what's going on. We get back the answer, which is going to be the value of, what was it, BTC in terms of USD. So if we wanted to actually deploy this, right, we need to compile it. I have my auto compile turned on. We will deploy it. So like I mentioned in Remix, you have VMs that you can deploy to. If you want to deploy to an actual network, you could use your inject provider. For me, that's going to be my MetaMask wallet. So let's go ahead and deploy this. Should get a confirmation here. Maybe. Give it just a second. Well, wait, any questions? Cool, so it's deployed and it has our one function, right? Get latest data. And so we get back the price of Bitcoin in terms of USD. Now, if Bitcoin's worth this much, like, you know, it's going to be a new day. This value is really big. The reason it's so large is because Solidity doesn't have the concept of decimal places. So when it comes to this, we need to insert our decimal places. So it's 1, 2, 3, 4, 5, 6, 7, 8. So the actual answer here would be 27,010. you can find out how many decimal places are in each of the different responses. You can see it in the documentation. There's another function you can call to get that information. But most of the time, if we're talking in terms of a fiat currency like USD, it's going to be 8. If we're looking at two cryptocurrencies, comparing them to each other, it's going to be 16. So it's just something to keep in mind. But yeah, Solidity doesn't have the concept of decimal places, so we have to kind of like artificially inflate just to keep that accuracy in there. So that's the basics of data feeds. There's a question, what tool do you prefer to create your accounts with? I'm not sure what you mean by create your accounts. If you're talking about wallets, that's just going to depend on the use case. For all of my demo stuff and dev stuff that's like this, I just use mostly MetaMask or the Brave wallet. But if I'm not answering your question, Luke, feel free to like clarify for sure. So yeah, that's the basics of data feeds. They will be updated when those thresholds are met. Using them though, you'll notice like this get latest data. It's a blue button here, which in Remix signifies that it's like a view function. You don't have to pay for it, right? So once that data is stored on the blockchain, anybody can access it, anybody can read it. There are questions sometimes people ask, like, so if I can just read this data for free, like how do y'all, why do you put it out there? The response to that is, if you're building a project that's going to be using information like this, right, and your project relies on it, then it becomes kind of necessary for you to incentivize that data to be there and be robust and be accurate. So when projects start to use this, they will usually compensate the Oracle providers to have that there. But yeah, I think that's kind of covers the basics of this. Again, like, huge shout out to y'all at Moonbeam for like having all of this here. Like, this Chainlink Oracle doc is fantastic. Like, if you just wanted to stay on this page here and stay in the Moonbeam ecosystem to go through this information, it's a great tutorial as well. And I know we talked about the Bear Necessities Hackathon. So Chainlink is offering 5 different prizes of $2,000 each for anything that uses basically a Chainlink product, so data feeds, to make a on-chain state change, right? So what that means is, in this example, we're getting back the data, right? But you need to actually do something with that data on-chain, like actually make a change on-chain to do that. Since BRF, there's a question here. Since BRF is not yet available on Moonbeam, I'm thinking of using Bitcoin price plus percentage operation to get a random number. Do you see any problem with this? Okay, so I know I was looking through the documentation earlier that Moonbeam, and Kevin, feel free to like pop in here too if you want to add more around this. I know Moonbeam has some docs around random numbers. I will just say something like, yeah, there he's putting in the chat, something like using the Bitcoin price. It depends on what you're doing with the random number. If there is a real true need to have a truly random number, things like using that Bitcoin price and then a modulo operation on it can be risky. So just to back up and think about like a traditional way that people will do randomness on blockchain applications is to use the current like block hash and do something similar, right? Because you, in theory, don't know what block hash is going to be used, and that should work, except for the fact that when you're mining that block, you can see what the block hash is going to be. And so while the outcome is in theory random, it's not random in the way that people normally think of. What I like to think of it as, it's kind of hard to explain this. What I like to think of it as is, if I have a dice that I'm rolling, the outcome of that dice is random, right? But if I have the ability to re-roll the dice and then say that's the roll that I want to count, it suddenly becomes not really random, right? If I can control which of the random outcomes is the value that gets assigned, then it's not really random. And doing stuff like that can be kind of abused in the same way, if that makes sense. So it's just something to kind of keep in mind. It definitely will provide you with a pseudo random number. But yeah, it depends on what you're doing in your game, right? If it's just for fun, it would work just fine. But yeah. All right. Are there any other questions, thoughts? That's a great question, though, about the randomness, for sure.
So one quick question for you, Richard, is for aside from price feeds, right? On other networks, like Ethereum, Chainlink offers different types of data, such as like, is it inflation data for like other types of real world assets, I suppose, or like asset prices, like stock prices? Is that something that Chainlink offers as well?
Yeah. So we offer. So like here in the docs, you can see we offer proof of reserves, which is going to be like proof that there is the money that people say is there. We do on a couple of chains offer NFT floor pricing feeds for some NFT contracts. We have a rate and volatility feed, which at this point, like we're starting to get to the edge of my financial savviness. But yeah, we do offer that as well. So most of these though we're not talking about stocks specifically. These are going to be more crypto-based assets. There's a question here. Touch on the current price feed support for the MB ecosystem. Sure. So if you take a look here at data.chain.link, and there's two ways you could do this, right? You can go to data.chain.link. There's probably more than two ways. But if you go to data.chain.link and you filter the networks here, and you just search for, Moonbeam, we can see here the two Moonbeam and Moon River networks. And so we can look through this list, and you can see there's 45 total. So you can kind of go through all of these different values. The other place you can go is in the documentation under price feeds. This is docs.chain.link here. And then you can see the different networks here. So we have Moon River and Moonbeam. If you click on that, it'll actually give you a list here with the addresses as well. And then lastly, I'm going to talk to the docs team. I realized this just this morning preparing for this workshop. If you head to the Moonbeam docs on Moonbase Alpha, there is and Kevin, you may know, is it because, I don't know, are these like a different proxy setup or something maybe? I don't know. If you hit the Moonbeam documentation for Moonbase Alpha, you can see a list here.
For Moonbase Alpha, for the testnet. Yep. And some of the addresses could be different across each network. They might not.
Right. Yeah, that's a good point. Like the addresses definitely can be different from network to network. These are all great questions, though. Any other questions? All right. Well, I'm going to stop sharing my screen then.
Cool. Well, thank you so much, Richard. And I'll just give a quick, I suppose, introduction to some of the remaining workshops that we have coming up this week and next week. So Stealth Swap is going to have a workshop on Friday, 2 hours later than this. We'll then have Biconomy coming up next week, which is next Wednesday. We'll have a subquery one next Monday, and we'll have a Moonbeam one, which is next Tuesday. So all this information is on the hackathon site at moonbeam.hackerearth.com. We should put that link in here. And if you haven't signed up yet for the hackathon, go ahead and register. You'll get email updates and things like that. So very important to get registered there. And this is a major hackathon. We do these hackathons a couple of times a year. And so this is our first, big one for 2023. And, we have support from a huge number of important sponsors I'm very grateful for Chainlink support. There are also opportunities for builders. Even if you don't win a prize, you can get AWS credits. All startups that participate, all projects that participate in the hackathon are eligible to apply for credits. So that's a very special surprise. There will be more opportunities for help if you're working on your project and you find that you have questions and you need support. You can get help in the Moonbeam Discord. That's discord.gg/Moonbeam. And we will direct your question to the right place. So if it's something that we can't answer, then we'll go ahead and get the right people involved. And I think that's it for my kind of wrap up. Was there anything that I missed, Richard, in terms of Chainlink's bounties and participation in the hackathon?
No, I don't think so. Yeah, this is great, and I appreciate the audience participation. Like, to all you ask questions, it makes my job more interesting instead of just talking to myself on a screen.
This was fantastic, Richard, and you have a very smooth and clear way of explaining everything, which I very much appreciate.
Thanks. Awesome.
All right, everybody. We'll see you. We'll see you next time. Thank you so much.